Coming up, we have a keynote from Manish Kothari. Manish serves as the Senior Vice President of Software Development at Silicon Labs, a leading provider of silicon, software, and solutions for a smarter, more connected world. He also leads Silicon Labs' presence in India and is responsible for growing wireless engineering talent, building scalable infrastructure, and fostering local partnerships in Hyderabad, the company's newest and fastest growing wireless development center, and throughout India. He has more than 20 years of technology management experience and has built teams of more than 1,000 wireless developers and system engineers and holds several patents. Manish graduated from the Indian Institute of Technology, Madras, and received his master's and PhD from Massachusetts Institute of Technology. Thanks for being here with us, Manish. The floor is all yours.
Thank you so much. Thanks to the VLSI conference organizers for giving me an opportunity and Silicon Labs an opportunity to talk about IoT. What I wanted to do today, folks, is talk about promise of IoT, and I think in the sense I wanted three stories to tell you. First, IoT does appear simple, like you connecting bulbs, appliances, but there is incredible complexity there. So there's simplicity and complexity. That's one story. The second important one is that these solutions are transforming a variety of industries and impacting and improving lives. So I'll show you a use case, a study there, hopefully to give you a sense of that. The third part of the story is my belief that IoT will disrupt multiple industries in the coming decade and beyond, and hopefully excite the imaginations that all of us have to think about what the future could look like, because it's not defined yet, and there is just infinite outcomes available. So it's exciting there. With that, what I thought is I'll do a quick intro of Silicon Labs to set the stage, who we are, because that gives us a background of the stories that we are telling, that I'm going to be telling you. Silicon Labs is a leader in wireless connectivity, intelligent wireless connectivity. If you look at it, our revenues have been growing phenomenally. The market opportunity is huge. Lifetime revenues are high, and we have a very robust offering of wireless connectivity solutions. So when you look at the application diversity, the customer diversity, very hard. We're not, and we'll talk about this brings another set of challenges. Technologies are very diverse. There's about 50 plus wireless protocols that run on our platform today, 50 plus, okay? And geographies, very diverse set of customers, applications that we have to serve through our integrated hardware and software platform. What do we do? In a very simple thing is we connect different applications to the cloud or bring them online through a variety of different wireless protocols. What does our SoC do? Our SoC senses and controls, it computes, it infers, and I'll talk about it. It also connects, the communicate part of it. And security, as one can imagine, in IoT is paramount. It's front and center of what we do, right? And these SoCs have to last on a 10-year life on a coin cell battery. So very, very tight integration budget, if I may say that. Area is extremely small, power budget extremely small, and you have to do all these functions. When you look at inference, what is happening in the inference is we see a development of what we call as a micro edge. A micro edge is nothing but where your sensors and devices are residing. So think of it as, your glass breaking sensor, or a predictive, or a sensor that's a vibration sensor that's on your machinery in a factory. These are where our customers and the industry is looking for inferencing. There are various reasons why you want them. A, it's low power. B, bandwidth. Transmitting large amounts of live data back to the cloud is expensive, has privacy issues. When you do inferencing right at the sensor or the device, you are taking care of security. You're sending that inferred solution or the inference across as opposed to the live data. So it gives you lower latency. It gives you a more secure solution, and obviously it's cost effective. So this is a growing use case where inferencing is occurring right at what we call as the micro edge, where the sensors and devices are out there in the field. Now let's come to the first story. Why is IoT complex, right? The best way to think about this is to think about an embedded platform. And I think when you look at storage, just to give you an idea, the storage in an embedded platform is of the order of megabytes compared to, let's say, a gigabyte in a mobile smartphone or terabytes these days in PCs. Very, very tight memory constraint. Power. I talked about the power budget being a coin cell battery lasting 10 years, right? That's kind of the extreme scenarios. Device lifetime, very high. They have to last 5 to 10 years in the field and be relevant. They cannot go obsolete, right? Very important point, and I'll touch about that. Cost, a fraction of what you would pay in a data center, right? So this embedded platform is highly constrained, and what we are seeing, and my belief is every embedded platform will become connected, will turn wireless over time. It's just, we see that happening, and there is a big reason why that trend will continue. So what are the vectors of challenges? I wanted to touch upon a few to give you an idea of the complexity that we have to deal with. First one, multiple wireless technologies. We talked about Wi-Fi, Bluetooth, Zigbee, Z-Wave, proprietary, Wi-SUN, and a variety of different protocol stacks, ranges up to 10 kilometers, different combinations, peer-to-peer, mesh network, direct, and kind of a long range. And we have about 50 protocol stacks that run on a platform. That definitely has a lot of hardware, RF, and software co-design that has to occur to enable this for our customers. We cannot be having 50 different radios, for example. So it's very constrained in that way. There's a very tight area, memory, power budget for integration. We're doing sense, we're doing compute, we're doing inferencing, we're doing security, we're doing connect or communicate. So there's a complexity in the hardware software architecture. We don't have infinite area. We don't have infinite power in the context of what may be available in a data center chip, if I may draw that analogy, right? So there is a very tight constraint that we have to work with in terms of designing our solution. The other thing is it's a 5 to 10 year life. So there is a time relevance aspect of the hardware software. It cannot go obsolete. You have to be able to upgrade the capability of your devices or your hardware and software of an end customer product over time. So how do you think about hardware time relevance? How do you think about software time relevance? These are very, very, I think, very exciting concepts that we deal with. Really, really exciting in terms of how to make design time relevant so they don't go obsolete. The other key element is there are 10,000 plus customers. There are customers who could be as small as a mom and pop shop who are buying our products through a distributor online. So we need to have a zero touch hardware software integration. We cannot have a massive applications engineering support that may be required. It's not scalable. It is not the way we work in this industry. So the design simplicity and the ease of use is paramount, is how we think about our total solution. That's kind of the biggest filter we have to work through. Not easy, let me tell you, when you have to support this variety of customers seamlessly. The applications are very diverse. You can think of a light bulb to a glucose meter, to a machinery in your factory, to an asset tracker, to a pet tracker. We have diverse applications and various micro verticals with very different requirements for each one of them. In every vector, whether it is sense requirements, compute requirements. What does that mean? Your hardware software needs to be configurable. Very, very important concept. And you have to do quick turn derivatives. Not easy. You saw the cost profile of these devices that we work with. So all of these things to serve these diverse applications and micro verticals, which have different feature requirements, if I may say that, requires you to have configurability. You can't create one massive offering that just may not fit into the budget that a lighting solution could afford. right? They don't need the entire peripheral. They may need only certain features, which may not be needed by a medical device or a construction equipment. So a variety of different applications with a lot of micro verticals. This industry is very exciting. It's really, the open source momentum is tremendous. Let me tell you an example. Wireless tags on open source now. So if you go look up the evolution in the 15.4, the Zigbee evolution is going towards a new protocol called as thread. And that thread is called open thread. It's an open stack, anybody can download. And it's a community driven stack. So there's a whole momentum in this industry around open source, wireless tags, operating systems, tools, IDEs. So this really creates exciting challenges and opportunities for vendors like Silicon Labs to differentiate and think about our value chain, our design for differentiation, right? So it's clearly, it poses a challenge when things are open source, but it's an opportunity of how you think about design, how do you work within the community to scale. There's another exciting development, software as a service. I truly believe is a great opportunity that we're just scratching. And give you an example of the Silicon Labs custom part manufacturing service. What happens here is it's our customers can customize their parts in the Silicon Labs factories for several advanced features like secure boot, encrypted OTA, identity certificates, public and private keys. All of these things, the features, identities, and certificates are injected on the hardware securely, driven at the Silicon Labs factories. And they're configured. I remember the word I talked about, configurability. It's configurable, right? So this is a service offering. We make money from a service. Yes, we do as a silicon vendor. Not easy for those of us who've been in this industry for a long time, but it's something that is going to grow. And you think about the industrial and commercial segment where you have a large variety of customers who don't want to deal with the ecosystems of the Google and the Amazon for privacy, security, and their confidentiality, and simply don't even have the capability, right? So there's a variety of opportunities for players like us to really start driving. So you can see the breadth of offering and the challenges that we see. So it's a very exciting time to be here in the IoT world and in Silicon Labs. The second story that I want to talk about is it's transforming variety of lives. You know, you're not just connecting things or inferring things for the sake of doing or because it's cool. There's real impact. And what I wanted to do is talk about a construction use case. Construction industry is considered low tech, is considered something that doesn't make a lot of money. Things are not efficiently managed. You know, there's always late, right? These are all the kind of the mindsets that we come to think about. So what I thought is I'll play a video of one of our customers, their testimony.
2 years ago, we decided to go out and launch the first connectivity play for hand tools on construction sites, connecting data through our telematics device. And in there, we were seeking an innovative partner that could really not just leapfrog us into the Bluetooth space, but also give us a competitive advantage that allowed us to really put forward a solution that the market hadn't seen before. Silicon Labs to us represents a trusted partnership that has demonstrated its worth and its impact to Track Unit's business for years now. 2 years ago.
Now, what are the key pain points that that are being resolved? How are these tools and machines and equipment being used? What is their utilization? What are their efficiencies? Very critical to making money, delivering on time. How do you service and maintain them? When do you need to service? How do you have secure access? Right? Some of these constructions are occurring in areas where there is either problems in terms of danger of operation. Let's say it's a mining operation, for example. You have to think about personal safety and all of that. So how do you ensure secure access? There's a variety of scenarios. So these are just some examples of the pain points that are SOC that we have can solve and is solving, right? This is just one industry. So hopefully this story around it's transforming lives and businesses kind of resonates with you. Nobody's going to give us a lot of money for being cool, right? There is clear problems that we're solving that are improving lives, improving businesses, their efficiencies, and the money that they make. The third and the most fascinating part of it, which is what I really enjoy as well, is what will happen a decade from now. I believe IoT will disrupt multiple industries in the coming decade and beyond. And I want to walk you through a journey to show and hopefully convince you that this can happen. The first thing that I always remember is innovator's dilemma, right? Clayton Christensen at HBS talked about this, has very nicely articulated disruption occurs by technologies that are generally simpler, cheaper, and smaller to use. They're typically at a performance that is the lower end of the market. But then over time, they improve where they become good enough for the high end of the market, right? This has occurred time and again. You've seen the history of disruption. I'm giving you just some examples in the tech industry. It occurs everywhere. You can think of servers that PCs disrupted. You can think of cameras, audio players, PCs, GPS, all of them that have been disrupted by mobile to some extent, right? To a large extent in some cases, and to some extent in some cases. And hence, it's very likely that IoT will disrupt multiple industries in a decade and hence to come. What those are, that's something for us to imagine and shape. And that's what excites us every day when we work at Silicon Labs. Now, let me give you a story and draw a comparison of the biggest disruption in the tech industry around mobile, right? Let's see what happened there. And is this a good predictor for IoT evolution? So when you look at mobile industry, roughly, 1980s was 1G. Actually, the cell phone started in 1973 through a Motorola, but kind of 1980 is really, this decade was around 1G. Then you had 2G, the digital cellular. And the 2010 was around 3G, the mobile broadband, the BlackBerry explosion, people getting email access, being able to browse the web. And then you had the 4G, massive explosion of real smartphone use cases, and the 5G in 2021. When you look at what was happening on the communicate piece, it was really around voice in the 1G, 2G, and then it turned to data in the 3G, broadly speaking, right? And you can look at how the throughput or the data rates kind of exponentially increase to a point where 5G promises to deliver about 10 gigabits, insane amount of speed. There was a high level of integration in mobile phones that occurred. Compute grew from a single core to 8 plus cores of 3 gigahertz plus, right? So a variety of different performance core, power core combinations that have kind of grown exponentially. Sense capability started. And I think this is something, it's not totally accurate. I did the best I could to get the data from the internet. But, when you look at things like camera, touch, ambient light sensor, proximity sensors, accelerometers, they really took off in the early 2000s. So sensing became a very key part of that integration journey that is just continuous to grow in the smartphone. Location started with GPS in the 1990s. Inference, predictive test, for those of us who can remember, started in the late 1990s and only started to, it's only expanded tremendously with facial, voice recognition, AR, VR, and I think we're just at the beginning of what is yet to come. Security probably started earlier, but I was looking at ARM's trust zone kind of avatar as a way to kind of think about secure, and that's in the early 2000s. Software, big amount of integration and change. We had an OS, Symbian, Nokia, full web browsing, an app store, a Brew app store that Qualcomm, kind of the leader in smartphones or mobile, pioneered. And then now we have a full play app store, and software continues to grow in strength here. And think about the process nodes, right? We started from 3 micron. Now we're looking at 10 nanometer or better. And there was some interesting architectural changes that occurred, which is this whole digital RF separation. Somewhere in the late 2000, and early 2010, right? The separation started. So you can see very high level of, what does the story tell you? High level of integration of the various functions, compute, sense, gaming. All of these started to dislocate several and disrupt several industries. Now, when you think about where is IoT today in our journey, we're probably here. From a process node standpoint, in terms of our inferencing capability, in terms of our compute capability, we're nowhere close to gigahertz, right? We have sub gigahertz capability today. So very, very early days for IoT. So very likely that as this Moore's law progresses and the sense of integration kind of progresses, there will be dislocations that vendors and players like us will tend to benefit from. So this is my hypothesis. Now, if you believe with that, let's kind of walk through what the future could look like. And this is something that is super exciting to me. Some of it may be very crazy, but the more insane and the more crazier the idea, the more exciting it is, to be honest. When you think about, let's start with, you could have a very high level of function integration driven by Moore's law, right? We normally think of Moore's law as digital integration. Maybe Moore's law doesn't apply as directly to analog integration, but think about ways, when you look at sensors, there's a variety of analog front end on the sensors that can get integrated. So there's going to be a high degree of integration, but in the constraints of preserving power, area, memory, budget advantages, just like smartphones had a constrained power budget relative to PCs or servers. So that constraint remains. So there's a high level of integration that will come in decades as we just go down this Moore's law journey that we are yet to traverse. We're very early stages. You can think of a variety of cloudless architectures. We today have mesh network for latency, for privacy, for cost. In fact, there are some companies already thinking about it and piloting how can I do peer-to-peer cloudless architectures for these reasons. I believe a lot of these will develop for the reasons that I highlighted, privacy being one and latency being another. Think about a self-organizing network. We have 50 plus different wireless protocols which serve a variety of different needs. Bluetooth has a different role than Wi-Fi, then a sub-gigahertz protocol, which gives you a range of 10 kilometers. Think about these variety of different protocols that we as consumers don't have to worry about, that self-organize in a way, and maybe think of it as science fiction, kind of as a shield around us. It could be us or an object or a thing that follows us, monitors us for intrusion detection. They change the protocols on the fly. They help you with location. They give you mobility. So a variety of different things can happen, right? As opposed to saying, you're stuck with Wi-Fi or Bluetooth. It's really how do these networks, and we are positioned because we have a modem and an architecture that already can run 50 plus different wireless protocols and stacks. So we can self-organize these networks, right? This is just thinking 10 plus years. The other very interesting thing that I am excited about on software is scaling by zero code software. We're in a world when you have infinite applications and use cases, right? I talked about we can't have a massive applications engineering team to serve 10,000 plus customers. The world will be different where the customers can take the code, drag and drop connectors in a visual platform, and the code is outputted and the product is ready to go. I believe this will also filter into Silicon Labs. We will develop our own zero code software tools to accelerate this infinite application and use cases that is available. Simply hiring software developers is not scalable, right? We have to get to a point where we enable even simpler capability, if I may use that word, for people to exploit this platform. So this is a journey that will happen. And you can see signs of this today already, in the IDE space of this occurring. And obviously in AI, ML, a lot of startups and companies have come kind of promising around zero code, no code development. I talked about open source platform. That journey started. We have only talked about open source software. Think about open source hardware. And for those of you who have not seen, go check out the Arduino projects today. You have open source hardware. Yeah, it's it's boards and layouts that you can go build devices. But think about what it could be 10 years from now or 20 years from now. Open source hardware is exciting capability that will occur. And I think it will result in a variety of different models, business models, and that will disrupt the industries because of the need and the desire to go here as you're addressing that long tail of customers that are coming. Massive SaaS opportunity. I truly believe, I'm hoping, just like right now is the moment of semiconductors. I know semiconductors are in short supply, but hey, everybody know the positive side of that is everybody knows now what a silicon is. My grandfather knows, my grandmom knows. So it's very interesting. I do believe SaaS opportunity is really something in IoT that can finally allow a silicon vendor to capitalize on it, which has been difficult, right? It's been captured by the Googles of the world, the real software players. But I think there's a massive SaaS opportunity for configurability of hardware, software. Remember the time relevance, the security, and plethora of services, because you have so many diverse markets and applications. Some are small, some are big, that there's a huge opportunity for SaaS. And think about a large dense network of powerful nodes. Every lighting pole in your city today, like in our smart city offering, will have some sort of a SoC there that can self-organize. It could help you with autonomous robots, right? You can think about, you could position, locate, sense quickly. You can think about running blockchain on it because you have a powerful compute. Think about the 5G equivalent of IoT, right? 8, 10, 12 cores, significant compute power, memory is only going to grow, all of this massive network available. Yeah, security is a problem, but blockchain in general, local, gives you more security architecture. So a variety of different, I'm just touching upon a few of the vectors, but a huge opportunity ahead of us. And all of us here in the conference who can think, ideate, and shape this. So that's kind of my third story. And with that, I come to an end of my presentation, hopefully covering the whole picture around, it appears simple, but it's highly complex. It's solving real problems, really making a difference in people's lives and in the businesses. And the future is wide open. All of us can shape, and I think certainly as a silicon player at this VLSI esteemed conference, I feel very excited that there is a software play as well for the silicon vendors that typically has been very hard to grab or gain traction. So thank you so much, everyone, for attending and listening to me. And with that, I hand it back to Arpan.
Thank you, Manish, for that great talk. The way you presented the whole IoT problem from many different perspectives really gives us a lot of clarity in this area. I got a couple of questions lined up for you. So you mostly talked about industrial IoTG, but my question is more from a consumer IoT perspective. So here in India, we have a upwardly mobile population eager to kind of move up with their standard of living. And it seems like consumer IoT is the solution of the day. But at the same time, we are also a very price-sensitive market. And as a country, probably lack the capability to build these end-to-end products by ourselves. So where do you see that desire versus capability gap playing out? And how do you see that playing out in the long term?
Great question, Arpan. So I think when you look at what's happening on the consumer side, the reason I didn't touch on it is because I thought a lot of people may be aware. So today, when you look at India, absolutely, India has been a price-sensitive market. IoT in general is price-sensitive, and you can say India adds another layer of complexity around price. Today, you look at what is happening in a lot of the homes. There are solutions. There are a lot of startups which are building home automation solutions. They've been there for a long time. You look at secure cameras, you look at your lighting solutions, you look at your irrigation solutions, all of this. Granted, they work on the higher end of the market, no question about it, but those things have started. So there is a segment of the market in India today that's already benefiting in the consumer, let's call it upper middle class and higher. As these things drop in prices, as these things become more generally available, which will happen, is just to think about how smartphones were and how affordability has increased over time. There will be use cases even in villages and towns where in a home, you can benefit from having things connected. But yes, in India today, it's really around the upper middle class and higher, which is benefiting from this revolution on the consumer space. Now, on the industrial space, it's happening to everybody. You've heard about India's great push on smart metering. That's a great example. Smart city initiative that we are partnering with the Smart City Living Lab at IIIT Hyderabad and the MIT. Phenomenal work that's going on there to improve lives that impacts every citizen. regardless of their income range. But yes, in consumer today in India, it's more of an upper middle class and higher, but it will percolate down, as more players come in. And players come in, this is an opportunity for Indian entrepreneurs to think about how you can take some of these solutions and make it even lower cost affordable for a broader market.
Thank you, Manish. Thanks a lot. And that brings us to the end of this session. We really appreciate having you here today. Thanks a lot for spending time with us in VLSID 2022. Thank you.
Thank you. Thank you for my, really appreciate the opportunity for presenting here.